Welcome to another lecture. So in this lecture, I'm basically going to show you how you can use every circuit app to build an intuition. So let's talk about this simple circuit. You have two 1 kilo ohm resistors. So in total 2 kilo ohm resistors and 10 volts. So there will be a 5 milliamperes of current. And we can see that using any simulator basically. But what's special here is that you can actually see the flow of current as we imagine, right? So let me start the simulation. You can use the yellow button here on the bottom left corner, and if you press it, you will see that yes, it does show there are 5 milliamperes of current and the voltage of each node. So if you click on one node, you can see that there are nodes here. The whole node is highlighted. Either way, the point here is that you can see some green squares running around, right, flowing through the circuit, right? So this is what's showing the current. So this is not exactly electron, because electron is a negative charged quantity and it flows in the opposite direction of current. So it basically is showing the positive charges direction. So this is, you can imagine that this is just a charge flowing through, positive charge flowing through this. So the green squares are basically positive charges, right? And depending on the value of the value of the squares, you can say, okay, if the current is very high or very low. For example, if I add another resistance here, okay, so and if the resistance is very high, let's say 100 kilo ohm, so what you expect is that the current through this 100 kilo ohm will be lower because the resistance is higher, right? And if we simulate that, yeah, we can see that basically there is nothing. So okay, almost nothing, but there is a value. So I think if we lowered the value a bit, it will be easier. So let's use 10 kilo ohm. Yeah, now let's simulate. So yeah, you can see that the opacity is very low here. So it's really transparent and moving very slowly. This gives the idea that okay, the current is very low on the right side, whereas the current is very high on the left side. So this is very visual. Every circuit is very visual, and it also gives you the values like any other simulation. Okay, so why are we here today? So we want to actually discuss about capacitors and inductors. So let's use a capacitor instead of this resistor here. And what we can see that, okay, so we have already discussed this in the first lecture. I have said that if you have a capacitor, what it does is basically acts like open circuit, like it's basically an open circuit if you keep the circuit as it is. So as soon as you start the simulation, you will see that there is actually basically there is a residual current, so very low amount of current, but you can ignore that. But the thing is, there is a plus and minus charge here, indicating that there is some charge accumulated in this side, and there is a negative charge accumulated on the other side, right? And this causes there to be a voltage. Here you can see there is a 10 volt voltage. So that's why there is no current. Basically you have 10 volts on both sides of this resistor. As a result, because there is no voltage difference, there is no current, right? So that's the thing. And if you actually simulate it very quickly and pause it, you will see that there is actually 0 amperes of everything. Okay, so what we have seen that yeah, it actually basically works like an open circuit, right? But we actually don't see the buildup of the charge. So that's because in the last lecture I have said a capacitor basically reacts to change in voltage. So when the voltage is being changed, that's when the capacitor reacts, right? So how can we imitate that? We can either change the voltage here from 10 volts to something, or what we can do is basically add a switch here. So if you remember, a switch is basically nothing but open circuit and short circuit depending on how the switch is connected. So here's the thing. So if I don't press the switch, Basically the whole circuit is open and nothing's going on here, nothing interesting is going on here. But as soon as I close the circuit, you can see that the charge is building up, right? The positive and negative charge grows larger, the charge is building up, and the charge is still there. And if you have seen, if you noticed, basically there is a voltage build up here that just reached 10 volt right now. So let's do this again. I'm disconnecting the switch again. So now let's start the simulation. As you can see, keep your eyes on these things. Like you have 0 volts here. This will grow up to 10 volts. Okay, so this will creep up to 10 volts. You will see a curve there representing how the voltage is increasing. Also, you will see some current like we have seen there, but the current will die out very fast. Okay, the current will not be flowing forever like we have seen in resistive circuits, right? So let's turn on the switch. So keep your eyes on the voltage here and also how the current is flowing. So let me just start the circuit by pressing the switch. Yeah, so there is a current and now it's going away and the voltage has gone up, and it will eventually reach 10 volts, right? And also there is a charge. By the way, if I now disconnect it, you will see that the charge is there, right? This is how we actually charge a capacitor, and we also charge your batteries like that. So when you connect to your wall plug, it gets charged, it stores that charge, and even if you disconnect it from the wall adapter or your charger, the charge is still there, right? So that's the thing. This is why we say capacitor can store charges. Okay, so that's the thing. So for now we are interested how the voltage and current is doing things like that. Okay, how they're increasing or decreasing. So if we press the node here and press on this I button, we will be able to see the graph better. Okay, so if I start the simulation, you will see that there is a 0 volt line. So let me put it down here. So you will be seeing that there is a 0 volt line here. But if I connect the switch or turn on the switch, you can see that the graph grows and the voltage is growing it up to 10 volts. So it grows up to 10 volts. So we can see on the left we have the voltage 10 volts. So it goes up to 10 volt and very close, it comes very close to 10 volt, right? So that's the thing. So this is what the circuit is doing. Basically it's growing up to that. And what about the current? So now if I select the capacitor itself, that the element, and press the I button, we will be able to see the current. Okay, so if you remember, there is a huge current at first and the current dies very fast. So as you can see right now there is no current, but if I connect it, there is a jump and the current then dies, just like we have seen the visualization of the current on the circuit here, right? So that's what's going on here. But if you remember, I have already showed you the voltage graph, right? What happens when you connect the switch. This I have already drawn this graph in the first lecture, discussing how actually voltage works. You can also see the voltage and current together, but that's really nothing new, so I'm just going to skip past that. So you can have two graphs here, so they will be different color, they will be in different colors. So now let's talk about inductors. You can also add inductors here. By the way, in real life we use very small, so the farads and henrys are very large quantities. Usually we use like nano henry, micro henry, microfarad, milli henry, etc. But this is a simulation, so who cares? Let's exaggerate everything, right? So I'm using like let's use 5 henry. Okay, and let's see what happens to the current. Yeah, So I'm starting the simulation. So as you can see, at first there is no current. If I turn on the circuit, you will see that the current grows up to 10 milliampere. It will grow up to 10 milliampere. Okay, so okay, I can also squeeze the graph to see better. So yeah, look at that, it's growing up to 10 milliampere. It's creeping up to 10 milliampere. I have shown this exact example in the first lecture introducing capacitors and inductors, so please match with that theory lecture later, and of course play with this every circuit app by yourself. Okay, and also you can see the voltage here. So if I see the voltage and current graph together, so the green graph is the voltage, and as soon as I connect here, look, the voltage here is dies out very quickly. So you have to notice that the voltage and current switches their roles in capacitors and inductors. So in capacitors, voltage grows up to a certain value, and in capacitors and in inductors, current grows up to a certain values. And the other thing, that voltage, the current in capacitor dies out, and here the voltage in inductor dies out. So basically they switch their roles, right, because the equation is switched. Okay, so either way, this is basically what we are going to talk about, how this what the function is actually here. So like what we can actually plot the graph. Okay, so we can get what equation they are. So this is basically just an exponential graph, and this is what we are going to talk about, and that's what we are going to do maths on. Okay, so that's very important, but this is very good for building up an intuition. So what's happening here? The thing is, basically, we call this transient analysis. So because you have seen, if we wait for a day and turn back later, we will see that the current is basically, this will become shorted, as I have discussed in the first lecture. But transient analysis means that what happens in the smallest period of time, you are kind of zooming in that on that time, right? So that's what's happening. So let me actually simulate this in real time. So let's use the capacitor here. I just think capacitors are better for these demonstrations. So if I simulate the voltage here, so like I have shown, yes, the voltage grows up. But the thing is, you can see that this is 10 milliseconds. So there's a simulation speed, and right now this is simulating 3.84 millisecond per second. This is not actually real life time. We are kind of seeing things slowed down. So we can actually, I don't know, yeah, 1 second per second. So this is like in real time. So if we simulate this, let's see. You see there's like an instant jump here, right? There is an instant jump here. So that's the thing. We are actually zooming in on this part. So we are actually kind of zooming in on that transient part. Okay, so this is what we call transient part, the part that's actually changing. This is why we are calling it transient analysis, and that's what our topic is in the next lecture. Thank you.